There hasn't been a big earthquake on the southern San Andreas Fault for a long time, and we may have found a reason why.
Always hearing about the next big earthquake, and now scientists are warning that areas around the San Andreas Fault could see a strong earthquake as soon as this year.
The recent earthquakes in the Sierra are a great reminder of California's other very active earthquake zone. Now, when you think about earthquakes, you're probably thinking about earthquakes along the San Andreas Fault.
America's biggest fault line, the infamous San Andreas Fault, has long been the subject of ominous predictions. Imagine waking up to the sound of sirens blaring, the ground beneath you trembling violently, and the lights flickering before total darkness engulfs your city. Scientists have been warning us for decades, but a chilling new discovery in 2025 has reignited fears. Could the next major earthquake be imminent? And if so, how prepared are we? In this video, we'll dive deep into the latest findings near one of America's most dangerous fault lines. We'll explore the science behind these tectonic shifts, the warning signs experts are seeing, and what this could mean for millions of people living in the danger zone. But perhaps the most pressing question is, are we ready for the inevitable? Recent seismic activity near the San Andreas Fault has sent shockwaves through the scientific community. Researchers from the United States Geological Survey, USGS, have detected an unusual buildup of stress along previously overlooked sections of the fault. Ground deformation patterns and an increase in small tremors, often called foreshocks, suggest that the fault may be entering a critical phase. A 2025 study published by seismologists at the California Institute of Technology, Caltech, indicates that certain segments of the fault, particularly near the southern section, are overdue for a major rupture. The last time the southern San Andreas Fault experienced a major earthquake was in 1857, with the magnitude 7.9 Fort Tejon quake. Since then, stress has been accumulating for more than 160 years. Scientists estimate that a rupture of this scale today could result in a catastrophic event, causing widespread destruction in Los Angeles, San Bernardino, and surrounding regions. Infrastructure, including roads, bridges, and water pipelines, would face severe damage, and emergency services would be overwhelmed. What's more alarming is that new satellite data from NASA's Jet Propulsion Laboratory, JPL, has revealed subtle but significant land movements along the fault. This data, coupled with advanced computer simulations, has allowed researchers to refine their estimates of when and where the next major quake might strike. While predicting the exact moment remains impossible, experts agree that the likelihood of a magnitude 7.0 or higher earthquake occurring within the next 30 years has risen dramatically. California's earthquake preparedness measures have improved over the years, but many believe the state is still underprepared for the big one. Retrofits of older buildings, improvements to early warning systems, and public education campaigns have been implemented, yet gaps remain. Some cities have yet to enforce stricter building codes, and millions of residents remain unaware of proper safety procedures. Experts stress that personal preparedness, such as having an emergency kit, a family evacuation plan, and securing heavy furniture, is crucial for survival. Meanwhile, researchers continue to monitor the fault, gathering critical data that could help improve earthquake forecasting models. Cutting-edge technology, including AI-driven seismic sensors and machine learning algorithms, is being developed to analyze patterns in real time. These advancements may not prevent an earthquake, but they could provide a few precious seconds of warning, enough time to take cover, halt trains, and shut down gas lines to prevent explosions. As we stand on the precipice of what could be one of the most devastating natural disasters in modern history, the only certainty is that preparation is key. Scientists are urging policymakers and residents alike to take action now before it's too late. So, what can you do to protect yourself and your loved ones? Stick around as we uncover practical steps you can take today to increase your chances of surviving the next big earthquake. A disturbing discovery beneath the surface. Geologists have long studied the San Andreas Fault. But new seismic data collected in early 2025 has sent shockwaves through the scientific community. Using advanced underground imaging techniques, such as muon tomography and high-resolution GPS monitoring, researchers have detected an unusual buildup of stress along a previously underestimated section of the fault. This particular segment, located near the intersection of the southern and central portions of the fault, has not experienced a major rupture in over 300 years. Yet recent findings indicate that the region may be reaching a critical stress threshold far sooner than previously believed. But what makes this discovery so alarming? Unlike previous stress accumulations that have taken centuries to build, this one has developed rapidly over just a few decades. Seismologists analyzing slip rates and microseismic activity have found a pattern of accelerating deformation, suggesting that the fault is experiencing an increased rate of strain. Experts believe this could indicate an accelerated rupture cycle, meaning that the long-dreaded big one might not be as far away as we once thought. If true, this would challenge conventional models that have estimated a longer recurrence interval for major quakes along this portion of the fault. What could be driving this unexpected acceleration? While natural tectonic processes play a significant role, some researchers are beginning to investigate whether human activity has exacerbated the situation. Increased groundwater extraction, deep injection wells, and oil drilling in California have been shown to influence seismic activity in the past. These activities alter the subsurface pressure, potentially lubricating fault zones and encouraging slippage. If anthropogenic factors are indeed accelerating stress accumulation, it raises urgent questions about whether human intervention can mitigate the impending risk, or if we have already passed a critical tipping point. The most pressing question now is, how much time do we really have? While predicting the exact timing of earthquakes remains a formidable challenge, new models incorporating these recent discoveries suggest that the likelihood of a major rupture within the next 20 to 30 years may be significantly higher than previously estimated. In response, geologists and emergency preparedness agencies are urging for updated risk assessments and more aggressive retrofitting efforts to strengthen California's infrastructure. As researchers continue to analyze this alarming development, one thing is clear: the San Andreas Fault remains a sleeping giant, and it may not stay dormant for much longer. The silent signals of an impending disaster. Most people think earthquakes strike without warning, but what if we told you that the Earth has been giving us signs all along? Scientists studying microseismic activity have noticed an alarming trend: tiny tremors occurring in a pattern that suggests a major quake is building up. These tremors, often too weak to be felt, act like whispers of an impending catastrophe. They are caused by gradual shifts deep within the Earth's crust as tectonic plates grind against each other and build up stress over time. Seismologists have long suspected that these microquakes could serve as early indicators of a larger event, but the challenge lies in decoding their patterns accurately. While technology has improved, we are still unable to pinpoint the exact moment an earthquake will hit, making it difficult to issue precise warnings to the public. However, the biggest red flag comes from the rapid increase in earthquake swarms. These clusters of small quakes often precede a significant seismic event, and in 2025, these swarms have been more frequent and more intense than ever before. Could they be the final warning before the fault finally snaps? Recent data from seismic monitoring stations across the world, particularly in regions along the Pacific Ring of Fire, show a worrying trend. Swarms in California, Japan, and Chile have grown in both magnitude and frequency. In some cases, these smaller quakes have even triggered minor structural damage. But what is more concerning is the depth at which they are occurring. Many are happening closer to the surface, indicating that stress is moving upward, a telltale sign that a larger event may be imminent. Moreover, satellite imaging and GPS data reveal that the ground in some of these seismic hotspots is deforming at an unusual rate. This land movement, known as ground uplift or subsidence, suggests that pressure is building beneath the surface. Such deformations have historically been linked to major earthquakes, including the devastating 2011 Tohoku earthquake in Japan. Scientists are closely monitoring these changes, but without a definitive timeline, preparedness remains a major concern. Adding to the urgency, reports from researchers studying deep-sea fault lines indicate an increase in hydrothermal activity. This suggests that stress and heat are accumulating in the Earth's lithosphere, potentially weakening fault zones. While this correlation is still being explored, it raises further questions about whether the world is on the brink of a major seismic event. Despite these warning signs, earthquake forecasting remains an inexact science. Governments and emergency response teams are urging residents in high-risk areas to take precautions, ensuring they have emergency kits, securing heavy furniture, and reinforcing structures to withstand shaking. While we may not yet be able to predict the exact day or hour of an earthquake, the data strongly suggests that we should be prepared for the possibility of a significant event sooner rather than later. The silent signals are there. The question remains, are we listening? The Megathrust effect. Why this earthquake could be devastating. Not all earthquakes are created equal. The type of quake that geologists fear the most is a megathrust earthquake, an event where one tectonic plate violently slips under another, releasing massive amounts of energy. The latest research indicates that the San Andreas Fault is primed for just such a disaster. So, what makes megathrust quakes so terrifying? Unlike regular earthquakes, which shake for mere seconds, a megathrust event can last several minutes. This prolonged shaking leads to widespread infrastructure collapse, fires, and catastrophic aftershocks that can persist for weeks. The sheer scale of destruction from such an event could paralyze emergency response systems, leading to a prolonged humanitarian crisis. One of the biggest concerns is the possibility of soil liquefaction, particularly in areas with loose, water-saturated ground. This phenomenon occurs when the intense shaking causes solid ground to behave like a liquid, leading to buildings sinking or toppling over. Coastal regions are especially vulnerable, as liquefaction can cause entire neighborhoods to slide into the ocean or be swallowed by shifting land. To make matters worse, a megathrust earthquake could trigger a chain reaction along connected fault lines, potentially setting off secondary quakes in surrounding states. Could this event be the start of a seismic domino effect unlike anything we've ever seen? Scientists warn that stress redistribution following a megathrust event can increase the likelihood of subsequent earthquakes along other major faults, such as the Hayward Fault in Northern California and the Cascadia subduction zone off the Pacific Northwest. Adding to the potential devastation is the increased risk of tsunamis. Though the San Andreas Fault is not an offshore subduction zone like the Cascadia Fault, some scientists argue that a megathrust event in the region could still generate localized tsunamis in inland waterways, particularly in areas where the fault intersects with bodies of water. The 2011 Tohoku earthquake in Japan demonstrated just how catastrophic tsunami waves can be, leading experts to examine potential tsunami risks for California more closely. Beyond the immediate destruction, the economic toll of a megathrust earthquake would be astronomical. The collapse of critical infrastructure, including roads, bridges, and power grids, could cripple California's economy for years. The disruption of major industries, technology, agriculture, and entertainment would have global ramifications. Financial estimates suggest that a megathrust earthquake in California could cause damages exceeding hundreds of billions of dollars, making it one of the costliest natural disasters in U.S. history. Despite advancements in earthquake prediction models and early warning systems, there is currently no reliable way to determine exactly when a megathrust earthquake will occur. The best defense remains proactive preparation, including seismic retrofitting of buildings, emergency response training, and community awareness initiatives. Cities along the San Andreas Fault have taken steps to reinforce infrastructure, but experts warn that much more needs to be done to mitigate the risks associated with a quake of this magnitude. Ultimately, the question is not if, but when the next megathrust earthquake will strike. Given the immense potential for destruction, scientists, engineers, and policymakers must work together to ensure that California and the entire West Coast is as prepared as possible for the inevitable big one. Could a tsunami follow? The overlooked threat. Most people associate tsunamis with undersea earthquakes, but did you know that land-based quakes can also generate massive waves? If the San Andreas Fault ruptures with enough force, it could displace water bodies like lakes and reservoirs, creating inland tsunamis. This phenomenon, known as a seiche, occurs when a body of water is violently shaken by seismic activity, sending destructive waves sloshing back and forth. Depending on the size and location of the water body, the impact could be catastrophic, flooding nearby communities with little warning. In addition to inland tsunami risks, scientists have identified hidden underwater fault lines off the California coast that could be triggered by a major quake. One such fault system is the Cascadia subduction zone, which runs parallel to the Pacific Northwest but extends far enough south to influence California's seismic activity. If these faults slip, they could send devastating waves crashing into coastal cities within minutes, leaving little time for evacuation. Unlike earthquakes, which cause destruction within a confined area, tsunamis can affect regions hundreds of miles away from the epicenter, amplifying the potential for widespread devastation. The worst-case scenario is a double disaster: a high-magnitude earthquake followed by a towering tsunami. Major cities such as San Francisco, Los Angeles, and San Diego would face severe damage to infrastructure, power outages, and overwhelmed emergency services. Low-lying areas, such as the densely populated coastal communities of Orange County and the Bay Area, could experience waves powerful enough to obliterate buildings and submerge entire neighborhoods. Even regions further inland, connected by rivers and estuaries, could suffer flooding due to the backflow of tsunami surges. While we cannot prevent earthquakes or tsunamis, we can mitigate their impact through advanced warning systems, improved infrastructure, and community preparedness. Investing in seismic retrofitting for buildings, constructing seawalls in vulnerable coastal zones, and implementing rapid response tsunami alert systems could save thousands of lives. Governments and emergency planners must also prioritize educating the public about tsunami evacuation routes and safety measures, ensuring that residents know how to respond when disaster strikes. The question remains, is California ready? With the increasing likelihood of a major seismic event, proactive measures are more crucial than ever. The San Andreas Fault may not directly trigger a tsunami, but its far-reaching effects on secondary fault lines and water bodies could unleash a chain reaction of destruction. If we fail to prepare, we risk turning a natural disaster into an unprecedented humanitarian crisis. How cities are preparing for the inevitable. With the new 2025 findings, emergency planners are scrambling to update earthquake preparedness strategies. Cities along the fault line are reinforcing buildings, upgrading early warning systems and conducting large-scale evacuation drills. But is it enough? Some experts argue that no amount of preparation can fully mitigate the damage from a magnitude 8.0 or higher earthquake. The reality is that many structures, particularly older buildings, are still not up to modern seismic standards. And what about the people? A recent survey shows that nearly 60% of residents in high-risk areas do not have an emergency plan or survival kit. If a major quake were to strike tomorrow, how many lives would be lost due to lack of preparation? The countdown to disaster. How close are we? Seismologists believe that a major earthquake is not a matter of if, but when. The new data suggests that stress levels along the fault have reached an all-time high, meaning the clock is ticking. Historical patterns indicate that large quakes in this region tend to occur roughly every 150 to 200 years. The last catastrophic quake along the San Andreas Fault happened in 1906. That means we are now well within the expected time frame for the next big event. But what if the next quake is even larger than expected? Could the new stress buildup push the magnitude beyond anything we've seen before? And if that happens, will California and the rest of the world be ready for the aftermath? The Earth is always in motion, and while we can't stop an earthquake from happening, we can prepare for it. The new discoveries of 2025 have shown us that the San Andreas Fault is more volatile than we ever imagined. The question is, will we take these warnings seriously before it's too late? Stay curious, and who knows what new secrets the Earth will reveal next. Leave a comment below and let us know which fact surprised you the most. Do you think we're overdue for the big one? Or do you believe technology will help us predict and prevent disaster? We'd love to hear your thoughts and theories. Don't forget to like, share, and subscribe to stay updated on more amazing discoveries and hidden wonders from around the world. Hit the bell icon so you won't miss our next adventure.